All right, we're going to take a look at Golang error handling. Now, Golang has a built-in type called error, and we're going to use that to indicate anytime we have a non-normal state after running one of our functions. So in our example here, we're going to be reading a file, and this file is myfile.txt, which is in the same directory as this main.go file. And we're going to be returning two different things. We're going to be returning the content of that file as well as an error if we find one. Then, just for clarity's sake, we're going to go ahead and print whatever's contained inside of error, and then we're going to go ahead and do our error checking. If we have an error, we're going to go ahead and stop running it and print that out to the screen. But if there is no error, we will print the content of the file to the screen. So let's go ahead and run that real quick. All right, so basically we're going to assign two different values here, and we're looking inside the IOUtil folder, package, and we're going to use the read file function, and we're passing it the string here, which is the name of our file. And here we're just printing off our error. As you can see, we have nil. Now in Golang, the zero value for the type error is nil. The underlying type of for error is actually an interface, which is why it is nil. But we don't need to go into interfaces right now to understand how to use errors. But just understand the zero value for error is nil, and no news is good news. So if we see nil inside of error, that means everything ran just fine. It's the original unassigned value for nil. Everything went fine. And our error checking did not, since this is equal to nil, we have our not equal to sign. Since it is equal to nil, this returned false right here, and this if statement did not allow this block of code to run. And one of the reasons you're going to see this quite a bit, error not equal to nil, as a good source of error checking in Golang, is that if everything is good, like we said, it's going to be nil. So if it's anything else in the world except for nil, it's going to go ahead and return true and then run our error handling. And looking at this, log.fatal, it means it's just going to go ahead and stop our application, and then, hey, let us know what that error was. And finally, like I said, this didn't run. We're just printing our contents to the terminal. So like it says, contents of our file. And here's just two proverbs from Rob Pike. So clear is better than clever, and don't just check errors, handle them gracefully. And if you want more proverbs from Rob Pike, there are more of those out there. Anyway, let's purposely go ahead and create an error. So let's change this, instead of my file, let's change this to does not exist. As you can see, we obviously don't have that file inside this directory. Let's go ahead and run that. All right, there we go. So we went ahead and printed our error on this line. On this line, we're going to go ahead and print our error. So we get error, and it says open does not exist.txt, which was the name we handed it. The system cannot find the file specified. And they would be correct. That file just doesn't exist. And since our error checking here, since we can see our error is this value and not nil, since it's not equal to nil, it returns true. It's something besides nil. So it ran this chunk of code here, and it killed our application. The log, it likes to give us a time, and then it gives us this error that we had passed in, which we had just seen up here. We had printed off, but we just printed off again right here. And we don't even get to run this one right here. So anyway, one thing to take a look at, you do see error in quite a few different places. This is at golang.org in the FUMPT package. As you can see, you know, a lot of times we'll return two different values, and a lot of these we are returning an error. One thing you'll notice is it's commonplace for the error to be the value on the right. So just like in our code, if you're getting back, two values and one of them is an error, the error will usually be the last value that you're going to be returning. So let's go ahead and go over to our other example here. So in this other example here, we're going back to using our rectangle area function. Now, when we used this previously, you might have noticed that you were able to pass in a negative number. And we're not going to get a negative area for our, as a result. So we need to do a little bit of error checking for that. And we're actually going to create our own error. So there is a core package called errors. We're importing that. And there is a function called new. So we're going to create our own error here. And if we encounter that error, then we're going to go ahead and return that error. So let's give ourselves a little more space here. All right, so basically, we're going to go ahead and assign variable a an error, and we're going to run our rectangle area function. We're purposely passing in a negative number, which should throw an error. So looking at our code here, we're basically just saying if length is less than 0, which would be a negative number, and we're using the OR operator. So if either of these expressions come back true, then this block of code will go ahead and run. So if length is less than 0, or if the width is less than 0, it's going to go ahead and run this block of code. We're going to go ahead and create our special error that we created ourselves. You can put whatever text you want to put in here, and then it's going to go ahead and return, which means it's going to stop running the rest of the rectangle area function. We won't even get to the rest of this, which we don't want to if we're given a negative number anyway. So let's go ahead and run that. All right. So as you can see here, we printed off our error just so you can see what it is, and it's just our error returned is just like we wrote it up here. You cannot use a negative number to calculate area. Now here we returned our values. We returned, the value of area at the time would be its 0 value, so we would have passed a 0, and then error would have been this value that we just assigned right here. So looking at that, since error is no longer nil, when it's created it's nil, but when you assign something to it, it's whatever you assigned it to. We can see here when we get to if error is not equal to nil. Well, we know it's not equal to nil because we just printed something off. That's something besides nil, obviously. So it runs this block of code, and it printed that error off again for us. Now, if everything was to run correctly, it should go ahead and print the area at the bottom. And we're just ignoring that, since this will come back since it's nil, it'll come back false. It'll run this section instead. All right, there we go. Like I said, it returned nil, so it didn't assign anything. It just stayed the same, and we got 150 for our area. All right, so errors are going to just help you figure out anytime something is not quite right, figure out where something went awry, and in short, you can create your own errors to kind of make life a little bit easier. All right, I hope that was helpful, and I'll see you in the next one.